morning. My name is Dr. Ajit Kumar Panda. I am responsible for this pre-EDA tool course. With me, my team is Abhyarthana Bisoi, Shashwat Mahanti, and Gautam Ari. We have developed the course for this pre-EDA tools under the NMEICT project. The project name is Content Generation for E-Learning, VLSI and Embedded System Tools. It is a project from NMEICT, National Mission on Education through Information Communication Technology. It is a laboratory course, and as all of you know, the basics basically I would like to tell you. As all of you know, VLSI tools cost high. Few VLSI tools are Cadence, Mentor Graphics, Synopsys. For example, Cadence tools, which actually our institute has purchased, has cost us around 12 lakhs for 3 years. A private engineering college or general engineering college paying some 12 lakhs rupees per 3 years for 3 years is a difficult task. Whereas VLSI is a domain where the industry needs lots of the people. Therefore, how the students can use the VLSI tool, keeping it in mind, we have tried to develop the course materials and the solutions using the free tools, free VLSI tools. The number of free VLSI tools are available in the market, which actually the students should do it and use it. But unfortunately, the students do not know how to download it, how to customize it, and how to use it. One thing. Second thing is, these free tools are available in Linux platforms. In many colleges and in many places, Linux the students do not know in second, third year. So our aim is to how to understand the Linux also, and we have developed this course material in such a way that the course and manual is developed in such a way that the students can learn by themselves using the video which actually will be presenting and manual which we have developed. As I told you, my team is myself, Dr. Ajit Kumar Panda, Abhyarthana, Shashwat, and Gautam. What we have done it in this course, we have developed the initially we have developed the materials for the Linux, how to download the Ubuntu Linux, how to install it. For that we have manual as well as the video. Once you have developed it and once you install it in your computer, after that we have gone thoroughly point by point how to design the VLSI circuits. We have not gone for the bigger circuits. We have taken only the smaller circuits, and our basic aim basically in this course is to teach to the students how to use the pre-EDA tools. Pre-EDA tools we have used Magic and IRSIM. Therefore, slightly in this class for next 10 minutes I will talk what is VLSI, what exactly we will be doing it. Then in the next class onwards, you will be learning the tools and few of that will be taken by me, Abhyarthana, Shashwat and Gautam. So this is the Intel processors, recent one. If you look it and if you see, the million number of transistors has been used in this one. So how to design such big circuits basically cannot be done it in the hand, and the people must have to use the some VLSI tools to design it. And this is what actually, just because to bring it into the course, as I showed you, the nanostructures, it means that today's technology is at 18 nanometer technology, 35 nanometer technology. To have that technology, you cannot do it by hands and you must have to use the automatic process. And VLSI, to design this IC, VLSI tools are one of the medium through which actually you can design it. The cost and failure rates and all that, just you can go through these slides at your leisure and you see it. What exactly is the complexity, feature size and all that. I'm not talking much on that. This is what the microelectronics evolutions starting from 1947 to 2000, and VLSI, we are telling it, few people talks about ULSI, GSI and all that, but all these we call it as the VLSI. Then in microelectronic structures, if you go it, again, it will be inner substrate, active substrate, thick film, thin film, then the silicon, gallium arsenides, then MOS, MESFET, bipolar, CMOS, BiCMOS, PMOS, TTL, ECL, and all that. I want to show you just to say that, in this course, we have developed the materials basically for the yellow shaded regions. That in the microelectronics, we will take an active substrate made up of silicon in the MOS, and we will be using the CMOS technology. What I want to say here, we have developed the course materials for CMOS technology and how to design it using the free EDA tools. These are few points which are not necessary to discuss it. Again, I want to show you why we use the CMOS technology. Different logics are there, but aim of this course is not to go to that theory. So this is one, basically I have drawn it in terms of propagation delay and power. In terms of propagation delay and power, it is basically, we have seen it for the gallium arsenides, NMOS, ECL, CMOS, BiCMOS. So for different technology, if we look at power and delay, basically we will get it like this. But to compromise and to have the standards methods, basically we have used the CMOS technology, though gallium arsenide is better technology. And this typical ASIC design flow, ASIC means application specific integrated circuits. This design flow is requirements, basically you have to know it. Behavioral model, where we look for the timing, area, power and all that. We do the functional simulations. Then the RTL model, you have to write it. RTL simulations. VHDL Verilog, you have to write it again. Logic level, you have to define it. Gate level netlist, you will get it from that. Timing, power and gate level simulation, you do it. Floor planning, you do the chip area, then place and route, then basically interconnect cells and all that you will look for. Verification and testing, you will do it, and it goes to the chip fabrication. This is one of the ASIC design flow. ASIC design flow. I am not going in details of this one for the time being. We'll talk about this later on. But what this is basically digital flow. Digital flow using the semi-custom ASIC design technology. We are not using this technology or these models in our course. The other one is, okay, chip fabrication, post silicon and all that. Then the specifications, preliminary design, you do it. After that, you do the computer simulations. You must have heard, this type of simulation. You might be doing it in using the spice, which cost money. In our case, this first we will design the circuits. Let's say a CMOS. Then we will do the computer simulation. CMOS inverter, let's say. Are we getting the inverter characteristics or not? That we will do it by using one free EDA tools called as ITSIM. Then if it is okay, if it is no, then again we will go to the preliminary design. If it is yes, we will go and we will design the layout using magic tool. Using one tool called as magic tool. Then in layout we will do again the simulations. If it is okay, fine. If it is no, there may be problem in my preliminary design, there may be my layout design problem. And if it is okay, we will go for the initial fabrication or whatever it may be. That people talk it, test verifications and okay. We will do up to this actually. Let's say preliminary design, computer simulation. We'll do it by using tool called as it's layout design and computer simulation. Basically, we'll do it using Magic. Magic. So that's what you see. The job of the VLSI design engineer, highest job opportunity, and our target is this one, this shaded region. This shaded region. Clear? So what we will be doing it? We will be designing a schematic diagram that we will be simulating using eSIM. If it is correct, we will design the layout using Magic tools. So in this course, basically, we will cover eSIM and Magic tools basically. This is for the digital design, top-down approach, bottom-up approach. But again, let me make it clear: this process we are not following. There are different design methodology, custom design methodology, full custom, full control of design, best result, slowest design process, semi-custom, standard cells, gate arrays. These are few design. Out of these, PLA, PLD and all that, out of this, basically we will be using the custom methods where design is full control of design. Best result, slowest design process. That's true, but we'll be in this course we'll be learning the custom design methodology. We are not going for semi-custom gate array and all that. Classifications of VLSI design in terms of different ways based on design, front-end design, back-end design. So in our course we'll be covering both front-end design as well as the back-end design. Classification of VLSI design, front end, enter the design in one standard format which idiot tools can understand. Again, as I told you, I am not going in the details of this design. Just for the time being, understand it, we will be using the front end tools as well as back end tools. So these are on the front end tools in details, which actually gradually will be covering for the CMOS based design technology. Back-end design, this is on back-end design, which we'll be talking later on. Gradually you'll know it. This is the whole VLSI design approach. Just you can check it, see it. The total, both customized, semi-customized, everything is there in this design flow and roadmap. We are not covering this one for the time being. So such kind of things, design as it is told it, not possible. Therefore, challenge is how to cope with this design complexity, and that, as I told you, can be done it using the VLSI tools. Again, what kind of VLSI tools? No doubt there are commercial VLSI tools like Cadence, Mentor Graphics, Synosys and all that, which cost very high. In our case, the aim of this course is basically to learn the VLSI using freely available electronic design automation tools. So our learning is to basically schematic to download in one side, the other side is schematic to tap out. As I told, we will not go for schematic to download. We will go for schematic to tap out methodology. And our objective is, let's have a quick lab for the introductions to the software. Takes a simple design from schematic to the demo board automatically and give a demonstration. And believe me, from next class onwards, you will see it. We will go by point, line by line, so that you don't need any teachers for learning this course. So our learning in this course is schematic to tap out. And objective, theory of simple design, how to design the same using our free tools, Magic and it seems. This is what actually you can see the beauty of the Magic tools. You will learn it, will tell you how this inverter has come. This green one which you see, is the schematic diagram. You must have understand it. It is the CMOS design. Its simulation result below. That actually when you take it into the layout, the right side, the top diagram is called the layout. We'll teach you how to design this layout and how to simulate it. This is a NAND gate. Do you think, have you seen this kind of NAND gate? Otherwise, you will learn after the end of this course, you will learn how actually this NAND gate has been designed. And this is what actually simple 4-bit microprocessors, which actually we have designed it, our students have designed for this course using the magic tool. Using the magic tool, that's the powerful of the magic tools. And hence, learning the magic tools, basically, you will get the better understandings of the VLSI design at the initial level. I'm not saying that it is at par with the cadence tools or embedded system tools, commercially available tools, but it is a learning tools and you will learn it. And this is the open space we have kept you. In this course, you will take this microprocessor and maybe that you will design the control circuits. That's our and basic requirements, what actually we are looking for. It is not that you should have the VLSI knowledge. We are not looking for you should have the this knowledge, that knowledge. You should have the basic understanding of basic electronic circuit, analog electronic circuits, digital electronic circuits. And it will be better if you have understand the physics of semiconductor devices. Programming language, if you learn it is fine, if you don't, not necessary. So this course is meant for the students, those who have done a course on analog electronics and digital electronics. With this introductions, I want to end it. I will end it. The course material is available in our website www.nis.edu. You go to there. There you see the NPTEL course material. It is there in the Sakyat website also, and you download it. The download it will each of the course is around 10 MB. Each of this is 10 MB. The course has been delivered, as again I tell you, by everybody. At the end, let me say all of you thank you, and it is my acknowledgement basically to the NMEICT for providing MHRD for providing this providing the grant to develop this course. Many people have helped to develop this course, and we are thankful to all of them. Any feedback, if you want it, you can give it to any feedback you want to give about this course. You can give it akponda@nist.edu.